Okay, thank you very much, gentlemen. Appreciate that. I'd like to introduce the third member of the panel today. Mr. Austin Roberts is the Vera C. Rubin Observatory lead systems engineer, very critical position. And we're now going to actually go into the panel discussion. We put together some questions to start things off, but I do want to encourage our audience to participate through the chat function as well. And also encourage you to attend the meet and greet session at 12 o'clock for this particular presentation. So let me start with the first question. Gentlemen, what has been the most significant lesson for you as a project manager and safety manager for sustaining PTD leadership during this project? I think we can start with Austin.
Yeah, I think one of the most important lessons that we've probably learned on this project and looking at it from a systems engineering, a technical standpoint, is that safety has to be designed in. It's not something that you can do after the fact. You have to have a focus on safety from the very beginning. And the other lesson I would say is it takes continual analysis throughout every stage of the development of a project and constant communication. We always have to be communicating that safety is first. Schedules get crunched, people get fatigued, people get tired, and it takes constant communication to kind of remind everyone that safety takes precedence over anything else.
And I'll add a little bit to that too. So the stop work authority also helps with that communication too. It's not a bad thing. It's a good thing that if you don't understand a particular procedure or task or something's going awry, then anyone within the organization can do stop work authority. Also, I think important for this group of engineers is that if you're going to be a project manager, you can't just skirt safety to the safety department. So I'll just say that Victor and I have had a long-lasting partnership in safety management in this project. And I think that's very successful because he's provided that leadership along with me. But, people are going to listen to the project manager probably more than the safety guy. So he's been very good about that. And I really do appreciate it. And it's been a pleasure to work with him all these years.
Yeah, let me just, I think my answer would be something that we covered in the video. And I think I would just reaffirm the importance of establishing the cultures and the tools and the processes as early as possible, really at the very onset of the project, because these endeavors are long, they're complicated, they're unpredictable, as you might have seen in one of the slides there. And oftentimes the focus is during that early design phase, but really what happens is there's also design that continues on. When we get into fabrication and construction elements, it's easy to focus on the emerging issues that we're faced with. But without this strong background, without the culture, the tooling in place, it's just too easy to get distracted and to lose the focus on these really important principles.
Thank you. Gentlemen, we're already having some questions come in through the Q&A. So I'll try to alternate between our prearranged questions and some of the Q&A. First question comes from Jack Tollner, and it is, can you share with us the project's methodology to capture lessons learned that could then be leveraged to drive changes to the design standards?
I'm not sure which of us will take that one, but I think Austin could go on about certain types of lessons that we learn and some of the tooling we have in place for that. Certainly our registers on risks end up capturing some of these issues that are essentially lessons as well. And we have multiple JIRA projects where we're constantly monitoring and identifying the emerging problems that we face. And I guess I would have to confess that we don't have one system right now that is so robustly identified as this is where you log every single lesson that you've learned, because that's something that we all know we have to do. And at the sort of tail end of the project, we'll probably be spending some time reviewing what we've learned, some of those tooling, what some of that tooling content, and transferring that over to a single document that we will deliver.
Thank you.
I'll just quickly say that whenever we have a near miss or a got you, at least in safety, we do put together lessons learned, and we also do basically put out a flyer and a communication for recommendations from those lessons learned. Also, Victor, if you wanted to just quickly, there's another question about staffing and cost of the project.
Yeah, I was going to write that in the chat, but I can just tell you that we are a multiple agency project, and we started off at about 470 million for the NSF and about 160 million for the Department of Energy. And because of COVID and various other elements, we're about another 100 million on top of that. So I think in the video I said we were about a $750 million project. I think those numbers get you close. Forgive the rounding off. But we also, and one element I didn't include was even in that early design phase, we did benefit from about $40 million worth of private funding, which was really instrumental in reducing risks, identifying the designs, getting some long lead items going, and really was instrumental in getting us started with such a strong foundation. People, we've got groups all over the world. I think the numbers that I summarized in the video were, I would say we're a couple hundred people on project. Maybe I think our database has 350 people identified, not all of them full-time. And then of course the contractors provide enormous resources, and it probably doubles it for certain periods of the project.
Thank you. To that end, very appropriate for the second question, how do you implement PTD with multinational companies and contractors? How are they effectively engaged in the PTD processes?
So I'll comment on that first. It is certainly a challenge when you have people from all over the world coming together to work on a very complex and very large project. But what we did is we actually wrote into all of the contracts statements of work as well as requirements, requiring that all vendors follow a similar hazard analysis process that we tailored from the MIL Standard 882. And so all of those are written in as requirements, they're statements of work. So we have all of the vendors kind of sharing our same culture, not just when they're on the summit, but even when they're doing the design and development process in their factories all over the world. So that's one way that we really tried to implement PTD across, several contractors all over the world and trying to get that unified methodology.
And then added to that, we budgeted the time to spend with those contractors to review, to teach if they needed to be, review and monitor what we expected from the hazard analysis process. And then I think the other thing that I thought of just recently is that, many of our staff members are bilingual in various languages, especially in the safety group. We have most of that staff, both English and Spanish speakers. So that also is very useful as well in multinational projects.
Victor, do you have anything to add?
Yeah, I think I would just emphasize what Chuck said. Really investing the time. You really want not just the contractors, but as I pointed out, we are a multi-agency. We have many, many, many partners and collaborators, contractors, et cetera. And it's really important that they don't just understand the tooling and the requirements that Austin said, but that we take the time to make sure they understand what we're looking for, but also why, and really get a partnership on collaborating on all of these objectives.
Thank you. We have a question from Mark Martin. Can you give some examples of hazards facing maintenance personnel that were mitigated or eliminated during the design?
Okay, that sounds like something for me. So I'll try to make it really quick. One of the things, so since I was involved in the operation of telescopes that were built primarily in the 60s and perhaps the 70s, I found that engineers were really looking at the scientific goals of building those telescopes rather than the maintenance of those telescopes. So one thing that that I actually brought into the equation is, how do you lift that motor out of that gearbox? How do you provide fall protection for people that are climbing around the telescope proper? So we provided that fall protection tie-off points in many locations on the telescope to help those maintenance people safely do whatever work they needed to do to maintain the telescope. So that's just one of hundreds of examples.
Is there not a deployable platform that is integrated into the telescope?
That's the other. So in order to access the camera itself for maintenance while the camera is on the telescope, there are deployable platforms provided. We provided fall protection for those deployable platforms. We also provided screens, so when they were very near to those mirrors, they didn't get vertigo because of depth perception problems. So there's another example for an example.
Thank you.
I think I would just add one. When you're dealing with machinery that is largely automated, one of the large hazards that you have is motion of the machine unintended while someone is accessing or within a hazardous distance to that machinery. So we have devised, we really have kind of like two primary things for that. One, we have a global interlock system. So this system, will automatically shut down motion of equipment when people access certain areas of the observatory, or if certain motions of machinery could also damage the system itself. But we don't rely on that for maintenance scenarios. So we have implemented a very strong lockout tagout where we are not counting on interlocks to prevent motion when we are accessing it in maintenance scenarios. We have to de-energize the system so that someone from Tucson, where we're headquartered, cannot accidentally move the telescope to do some testing of a software update or anything like that, not knowing that somebody is performing physical maintenance on the summit during that time. So lockout tagout is something that we preach constantly.
Yeah, that's a good point, Austin. And so the other thing too that we didn't really mention is that we consider the telescope a robot, and it's a very quiet robot because of the way the motors are. So they don't make a whirring sound. It will just move, and there will be no noise. So that's one of the reasons why we have the global interlock system and other control measures as well.
Next question. what means and methods do you use to track daily, weekly, monthly, or longer risk mitigation activities consistent with PTD goals and objectives?
I think I'll take this first. So we treat every mitigation to every hazard that we have in our hazard analysis as basically the highest level requirements that we have. And so we have integrated the verification of all of those mitigations, whether it be performing a test to make sure that the mitigation is working properly. If it's a procedure that is supposed to have steps in it that tells you, what to do or what not to do to avoid a hazardous situation, we go through a rigorous systems engineering process to capture the verification of every mitigation. And this is a continual process that we do throughout the life cycle of this program. So even as we're going and learning things about how we're going to operate it, how we're integrating it together, how we're testing it, we have a constant feedback of identifying any new hazards that may exist, integrating those into our hazard analysis, defining the mitigations, evaluating the overall risk, evaluating the residual risk, and doing very detailed verification that those mitigations are in place.
And so some of the safety related things that we do to help minimize loss, are near, we already talked about this, but near miss and accident investigations with lessons learned and mitigations related to that. The other thing that's kind of cool is that we inspect our contractors' work areas as well, and we give them a percentage of compliance, which they really like, and it's almost competitive with the contractors. They're wanting 100% compliance. We conduct safety observations to correct real-time behaviors, and also we acknowledge safe behavior too. I mean, it's not all bad in safety, so when people do things right, we acknowledge that as well.
Thank you. Next, another question that came in from the chat. I think I'm interpreting this correctly. Did you identify accidents that occurred during the execution phase or during the planning, or were they unknown risks? I'm not exactly sure the context of this.
I think I can go with this. So this is the question about, I think this is the question about what do you put on the risk register? So I think most of our project managers know that there's some sort of documentation that we've identified risk. So we don't try to predict an accident. However, we know we do have a line item in the risk register that talks about serious injury or fatality and the ramifications of that. But we're not trying to predict every one of them. And there are other things that are on the hazard analysis process that actually make its way to the risk register. And then I'll stop there and see if Victor wants to say anything else about that.
I guess I would take a different tact or maybe a more simple approach to the answer. I'm thinking about all of the incidents and accidents and issues that we had. I don't think any of them were classified as a surprise. Certainly we didn't have so-and-so is going to put his boot into this hole, or is going to step off this plank or step on that nail. But in general, all of them were not a surprise. And I think each one of them, we looked back and said, well, we had mitigations, it just wasn't sufficient. There's no way you can mitigate absolutely every single risk that we face in these complicated projects. So if that was where you were going with the question, I would say no surprises.
I was also thinking that one of the most serious potential issues that happen relates to the remote site and transport to and from the site. And the fact that there was a situation where a truck went off the road and flipped over was bad, but the fact that your requirements in terms of the type of vehicle and seat belts basically saved the day. So you knew about the exposure from the front end, you implemented certain kinds of things to mitigate. And in some ways it sounds a little odd, but a success story. It would have been great if it didn't happen at all, but at least the result was mitigated because of your system and your culture.
Yeah, so I would just quickly say that, you know, it pained us greatly every time there was a road accident, because I mean, we had like 40 kilometers of gravel road up to the mountaintop. We had many people going back and forth the road. We did minimize that by buses and shuttles and all of that, but it was one of our greatest hazards with, I'd say, the lesser of control, right? Because there were so many variables related to that. So it was one of the most hazardous things for us to do, is to get to the summit and come down the summit.
Thank you. Next question. Why do federal funding agencies for large science projects require a system-wide safety plan? And do they actually include specific PTD standards?
Chuck, do you want to discuss standards, or I can launch in on sort of the higher level things, which is, let me just go ahead since you're still muted.
Yeah.
Look, these are expensive public projects, and we enjoy and we are in existence because of that public trust and that public funding. And we would really like Twitter to explode because of our accomplishments and not because of some failure. But seriously on that, the agencies also understand and encourage that with public money, that they would like there to be a bigger collaboration, that we would like to include more groups and get a broader inclusion to this great project. But along with that, they also understand that, as we've already talked about in this session, that giving more groups and more diverse opinions and outlooks and views and strategies does require a strong central management. We need to make sure that we are one collaborative and one strong functioning team and unit. So that's really where I think that the agencies have recognized it in both those aspects and really push this expectation on us.
Yeah, so I got caught up in the chat. So yes, so Jonathan, the Corps of Engineers EM is not necessarily required by the other federal agency of the National Science Foundation, for an example. So they have different standards. The DOE, Department of Energy, also has a different standard related to safety. They're probably a little more have more requirements, but basically, for our two federal funding agencies, it's basically a OSHA requirement. And early on, the MIL Standard 882, I'd say probably 20 years ago, they weren't even thinking about those kind of things. So the organization that we work for actually brought that into fruition, and basically the NSF is now expecting that from other projects as well. So great news. Thanks for the attaboys and all that. But you know, it's I really appreciate some of the ideas that you have there, and I'll be looking at the Corps of Engineers EM 385 too.
I mean, it might also be worth noting that this is a rabbit hole that one could go down. As Chuck points out, we have multiple agencies, and really what we saw, and not just multiple US agencies, but we also are building this facility in Chile. And so we have different national requirements there. And you could easily get yourself wrapped up in, well, what's that requirement? What's that requirement? But really, if you take a step back and just understand that the basic objectives for all of those requirements are the same, and that we project a way forward not necessarily to make sure we can check that specific box in some specific way, but that we as an organization are organizing ourselves and proceeding with all of that safety and all of that compliance and expectation in mind.
Thank you. Next question. Can you give examples of how PTD will be implemented as the project moves from construction into integration, testing, and validation, and finally into operations for the 10-year survey?
Yeah, I mean, I wouldn't say will be implemented. I would say has been implemented. So we are very much in the verification and validation phase, while some of the major subsystems of the observatory, like the telescope mount assembly and the dome, are still being constructed. But we have a lot of other subsystems that we are now integrating together. We're doing early verification of those systems. And so at this phase, like I briefly said before, you know, it is an ongoing process of performing hazard analysis. So during every phase, we go and we reanalyze the hazard analysis that we did previously. So when my team goes and we're integrating systems together and we're doing the verification activities, part of every test procedure that we do is defining what hazards exist during the verification of the system, because that oftentimes is in a different configuration. It's in a different part of the observatory than it will be in during operations. So you have different hazards that may exist because of these different configurations of the system. One example of this is, you know, we have a lot of our subsystems on what we call level 3, which is kind of like our maintenance platform. And we have the M2 mirror is just sitting on the floor. M1, M3 is sitting on the floor kind of near it. We have this camera cart assembly where we have the whole camera support assembly. All these systems integrated together sitting on level 3 on a cart. We set up a modified global interlock system on level 3, such that when we're doing these integration and verification activities, we're still working safely. Even though, you know, it's a totally different configuration than it will be. We actually went and we funded it and designed it and did these modifications so that we can have a interlock system on level 3 just during this period of time when we're doing this integration, waiting for the TMA to be constructed where we can get all this equipment on the TMA.
Thank you. Thank you.
I would also just say, Mark, real quickly, is that we intend to continue this process through operations. So the safety management process, as well as the hazard analysis process, will be adopted through the operations. There'll be different management. Victor won't be the lead on that, but the leaders of the operations group have basically said that they will take it on. And I think our culture will live on through the project and through operations.
Next question. What is the most significant change that you would like to see in engineering education that would help improve safety performance of projects? With all your experience, I'm sure you might have an opinion.
Well, I think what ASU is doing right now is pretty awesome. And thanks for the opportunity to allow us to speak to you about how we're managing our safety management process and hazard analysis process. There's so much more to it. But we, you know, again, we only have a certain amount of time to talk about it. I think you know, as we said, as Victor and I said before, no one said anything about safety when we were going to school. It was all about design. And then we learned later. So I really think that the ASU is doing a great thing for engineers and project managers.
I would just say from the systems engineering side of things, especially in aerospace and defense companies, systems engineering is a very wide field, and one aspect of that is some people kind of specialize in what you call kind of system safety. And what I would like to see now, I haven't been in a systems engineering graduate or undergraduate class in quite some time, but I would like to see this safety aspect. While safety typically is in like the NCOSE systems engineering processes, I would like to see it be more of a core class or core component of undergraduate systems engineering curriculum.
Yeah, and I could only repeat some of that. It's been a long time since I was in a formal engineering class, and I'm also encouraged by just this session or just this whole thing that ASU is pushing here. That gives me hope that my personal experience of an engineering education that seemingly was completely focused on the technical aspects. Yes, there was some maintenance, design for maintenance. Yes, there was some expectation that you had to operate it. But I left my education without ever really appreciating that safety can actually both provide you requirements and needs to be at the table in the iterative process of development. And that could have been just me, as Chuck has mentioned several times. I left engineering school without that appreciation, quickly came to it, but some of these other aspects, the systems engineering, safety, and so forth, was a void many years ago in my formal education, and I'm hopeful that that's changing, and it looks like it is.
Thank you. Let's circle back for a moment in terms of safety culture. Does PTD drive safety culture, or does safety culture drive PTD?
Well, I'll just say this. First, management drives any process, starting with the project manager. So it really is the leadership that gets what they want. So as far as, the difference between the two, they're both interrelated, right? So we set the culture via expected behaviors in the safety policy, and we set the expectations to identify and mitigate hazards by the design. And they're very interrelated, I think. Yeah.
And it's probably not a surprise that from my standpoint, I don't actually never thought of them as independent. I see them as the PTD and the culture are vital to one single project strategy and safety. And so I don't necessarily think about them as independent aspects.
Thank you. We have about 3 minutes left, and we do have some questions in the chat. Here's one. And this comes from Jack Tolner. Sounds like the project has a very vigorous and well-supported safety management system driven by a passionate leadership team. Can you share the real-time ongoing results?
I would say from from verifying hazard mitigation. So we have a very rigorous verification system that we have designed. We do model-based systems engineering, if anyone's familiar with that. And we also use JIRA to track the verification of all of our requirements. And so we have this system where we can do things in our systems engineering model, synchronize data back and forth between JIRA, and JIRA is a very real-time system. So we have integrated our hazard analyses, our FMEAs, our requirements. They're all integrated together in our systems model, and all of our hazards and hazard analysis is integrated with our whole verification strategy. So we track everything with a very high level of rigor, and we have integrated all that together. So it's not like we're looking at things separately in separate systems when it comes to looking at, kind of the system safety aspect. I don't know, Chuck, you could probably discuss about the, kind of the working safely aspect of it.
Yeah, I'm just getting tied up in the comments. So, Jonathan, yeah, actually, Mark has discussed this many times that maybe we should write a book about it. But okay, but I'll just say this. It was always a pleasure to work with Austin and Victor, because we never had any arguments about safety. It was always that we got to do what's right. But it wasn't always easy. Not everybody complies, right? So not everybody sees the same point of view. So we also have to enroll people in the possibility of working safely, and the ideas that we're trying to project, and the expectations that we have. We've done fairly well, and I'd say most of our organization and most of our contractors have complied with that. But sometimes it does take time, and it does take extra, effort to have people see a different point of view, right? So.
Okay, well, it looks like we've come to the end of the session, and this was incredible. Thank you, gentlemen, for joining me and us. Thank you again to ASU and all of the support in the United States.